In session 62, we're going to be squaring binomials. And remember, squaring means that you're going to be taking something and multiplying it by itself. Over here, what we have is 5 plus 4 in parentheses, and then we're squaring that entire phrase there within the parentheses. So what I've done is I've rewritten it over here at the right as 5 plus 4, parentheses, times 5 plus 4. So once again, to calculate this out, we're going to use our distributive property, and we are going to take each term in our first polynomial and multiply it by each in our second. 5 times 5, that's going to be 25. 5 plus 4 is 20. Then this 4 times 5 is going to be 20. Then lastly, our 4 times our plus 4, our positive 4, is going to be 16. If we take these and add them all together, 20 plus 20 is 40, 40 plus 16 is 56, and 56 plus 25 should be 81. Now let's come over here to the right and once again illustrate this with our rectangle. This length here is 5 plus 4, and this length across the top is 5 plus 4. So we're going to take each one of them individually. 5 times 5 is 25. 5 times 4, 20. 4 times 5, 20. And lastly, 4 times 4 is 16. And we can see that each one of these 4 parts corresponds to each of the 4 that we multiplied over here. So we can see that this here, this illustration using the rectangle, is going to actually show us and verify that our answer is 81 by showing us pictorially each of the parts that were multiplied together. Next, I've gone ahead and added a new problem here. I erased our 81 in blue, which was the answer to our first, and put in our second problem. Here we're doing the same thing. We're going to be squaring a binomial, but this time both of our terms are going to be variables. X plus y, parentheses, to the second. And that's what squaring is. Well, that's the same thing. I'm going to rewrite it as x plus y times x plus y. Well, let's start off and do each of the parts. What is this x times that x? That's going to be an x squared. What is this x here times this plus y? Well, that's going to be plus xy. Now, if I come here and take this y times this x, that's also going to be a plus y, or excuse me, a plus xy. And then lastly, this y times that y is going to be y squared. Now, let's see if we have any like terms to combine. We do. We have these xy's. So I'm going to rewrite the x squared. It takes care of that. And we have 1xy plus another xy. So that's going to be plus 2xy. And that takes care of these two terms. And then that leaves us with a y squared at the end. So we can see that for any binomial where you have two variables, x plus y, when you square it, your answer is going to be x squared plus 2xy plus y squared. And if we come over here to the right, and we're going to go ahead and visually show this, there's x plus y along the top, x plus y along the bottom. X times x is x squared. X times y is xy. Now this y times this x is also an xy. And then this y times this y is the y squared. And we can see that corresponds to each of the 4 that we had over here by just multiplying them across using our distributive property. This time we're going to take a look at a binomial that is having the first variable, or excuse me, having the second variable subtracted from the first. In this situation we have x minus y now instead of x plus y. X minus y, parentheses, squared. So I've rewritten that as x minus y times x minus y. Let's go ahead and multiply it out. X times x And do that there. X times x is going to be x squared. X times minus y is going to be a minus xy. And then this minus y here times this x is going to be another minus xy. And then lastly, a minus y times a minus y is going to make a positive y squared, because negative times negative is positive. I'm going to rewrite this by combining terms. The x squared is gone. We have 2 minus xy's, so we're going to have a minus 2xy here. That takes care of that one, and then we are left with the y squared at the end. So whenever you have a binomial, which is x minus y, and you're squaring it, your answer is going to be x squared minus 2xy plus y squared. Now coming over here to illustrate it, we're going to have an x here that corresponds to our first one, and then what we're going to have is a minus y in our second term. Remember, when you subtract, that's the same thing as adding the opposite of. So x minus y is the same thing as x plus a minus y. So that's what we have here. We have x plus a minus y. And we're going to have the same thing going down this way. We have an x plus a minus y. So let's go ahead and multiply it out with x times x, x squared. X times a minus y is a minus xy. A minus y times x is also a minus xy. And then a minus y times a minus y is a y squared. And as we can see, each of those 4 corresponded to each of the 4 that we have over here. So once again, the illustration of the rectangle is to help you to more easily visualize what is going on when you're taking polynomials and multiplying them together. Let's go ahead then and take a look at one final example. I'll go ahead and draw a line here. In this case, what we're going to have is in our first term, we're going to have an x plus a y. Then in our second polynomial, we're going to have an x minus a y. And we're going to use our distributive property to multiply it out. What is our x times x? That's our x squared. What's our x times a minus y? A minus xy. What's our y times an x? Well, that's a plus xy. And then lastly, what's a y times a minus y? That's a minus y squared. Can we combine any like terms together? Yes, we have a minus xy here and a plus xy. They cancel each other out to a 0. So what we're left with then is x squared minus y squared. And once again, to illustrate this with our rectangle, we're going to depict this as x plus y going along the top, and then x minus y, or plus a minus y, going along the bottom. Let's multiply. X times x is x squared. X times y is xy. Minus y times x is minus xy. And then minus y times a plus y is a minus y squared. And we can see that each of these 4 correspond to each of these 4 over here. Here's our xy and minus xy corresponding to these 2 that canceled each other out, leaving us then with x squared minus y squared. As a review then, polynomials are broken into 3 primary groupings so far. We have what are called a monomial, and a monomial is simply a polynomial with just one term. We have a binomial, which is a polynomial with 2 terms. And we have a trinomial, which is a polynomial with 3 terms. And if you want to just break apart the word a little bit, tri means 3, so that would tell you it's 3 terms. Bi means 2, so a binomial would tell you 2 terms. And mono, M-O-N-O, means 1, which would tell you that that's a polynomial with just 1 term. And lastly, here in our second bullet point, we have the 3 main types of monomials, or binomials, excuse me, that were being multiplied together. Here we have x plus y being squared, which gives us an x squared plus 2xy plus y squared. We also have an x minus y squared, which gives us an x squared minus a 2xy plus a y squared. And then in our last one, we have an x plus y being multiplied by an x minus y, which will leave us then with an x squared minus a y squared. Very important that you memorize these. You will be using these phrases here of squaring binomials for quite a long time. That finishes up session 62.